Good morning to all. Now, this is in continuation with the problems on Fourier sine transforms and Fourier cosine transforms. Here, we are going to discuss very important problem on Fourier cosine and sine transformations. Very important problem. Now, here, find Fourier sine transformation and Fourier cosine transformation of e power minus t square. Very important one. Very important one. Now just look at what function is given. Let f of t equal to e power minus t square. Firstly, I am going for Fourier sine transformation. Now, Fourier sine transformation of any function f of t is equal to integral 0 to infinity f of t. Because of sine, we are writing only sine term, sine st into dt. So, this is equal to 0 to infinity e power minus t square into sine st dt. Now just look at, if there were no power 2, e power minus t sine st, we had a formula, direct formula, but we are having t square. So in this way, what students have to do is that, now just look at how e minus t square can be integrable. In general, in this case, not integrable. For example, look at the function e power minus t square. Now, there is no question of direct integrability. No question. So, go back to the differentiation. If you go for the differentiation, what happens? E power minus t square, this will become e power minus t square. And for minus t square, it will be minus 2t. So, in order to make this integral to be integrable, there should be one more variable, t should be there, but t is missing. So as a student, now you have to make it that how to get t in the integral. You can't introduce directly t, but there is t in another word, that is sine st. For that purpose, let it be I. So I. Now just look at the integral is with respect to t. The integral is with respect to t. Now just look at one more point. What is differentiation of 2x? Differentiation of 2x equal to 2. That means d by dx of 2 equal to 2. But why 2 is coming out? 2 is coming out because of constant only. So all constants will remain same. In the same way, look at, there are two variables. One variable is s, another variable is small t. The integral is with respect to t. So we want to touch that integral. Now we are differentiating the entire integral with respect to s only. Very, very important. Students have to make it. Now this is what I. Now just look at. Now we have to get small t. In addition to this e power minus t square, then it will be integrable. How to make it? Here everything is with respect to t only. Here s is constant for this integral. Leave that t. S is there. If you make differentiating this integral with respect to s, with respect to differentiating, wherever there is s, remaining all are constants, all t's are constant. You are differentiating with respect to s means t will be constant for that differentiation. Then what will happen? T will come out. Understanding? Very important step. This is very, very important step. That's why this problem is very, very important. Now, let it be I. Now, differentiating I with respect to s, that will become 0 to infinity e power differentiate with respect to s, remaining all are constants, it won't be disturbed. E power minus t square same, here dt same, but for sin st, it will become cos st. Now in the st, you are differentiating with respect to s. So which one is constant? T is constant. Understanding? Now, we already get t. Now, to get integrable, what we have to make it? We have to make a constant minus 2. Understanding? Now, this is equal to take, divide by minus 2 and multiply with minus 2, it will become minus 2t. This is cos st into what? dt. Understanding? Now, take the entire term into, this is UV method. Now, let it be u, let it be v. Now just look at, this is minus of integral 0 to infinity minus 2t e power minus t square dt minus, now just look at, minus, what are the thing integral we got here? Minus of minus 2t into e power minus t square dt into differentiation of cos st. How much differentiation? Cos minus sin st. Now, with respect to t we are making. So, what is differentiation? For cos st minus sin st, t with respect to t. So, which one is constant? S is constant. This is dt. Now, between the integral 0 to infinity. No need to make it. Only just we are making this one. Now, just look at what we have here. Just look at, I am telling you. We are having what? Minus 2t e power minus 2t into e power minus t square dt we are having in this integral. The same integral just we have to have in the UV method of integration. Now for simplification, what value we will get? Now in this way, let minus t square equal to k. This will become minus 2t dt will become dk. This will become minus 2t dt. It will become what? dk. In the power, it will become e power k. For e power k, this is e power k. For k means what? Minus t square. That means what? For entire thing, this value will become e power minus t square. What are the value we are having here? Same value here we have to substitute. So this will become, now this will become, what is this value? di by ds. So di by ds is equal to minus half into, now for this one what will have? E power minus t square. That equal to e power minus t square. Now here, between the value how much? 0 to infinity. Next, dt minus this will become plus into s plus s plus s into integral 0 to infinity. On simplification, what we got? E power minus t square here. Same value you have to substitute instead of this integration. This will become e power minus t square into what we had? Sin st into dt. Into dt. Now this is dt. Now what we got, just look at. This is equivalent to di by ds, that is equal to minus half into limit, upper limit, e power minus infinity minus 0 plus s into, once look, this entire integral is equal to which one? This entire integral is equal to which one? I. So instead of that entire integral, which letter can we write? I we can write. Therefore, this will become Si. Now, this implies this is equal to minus half into e power minus infinity, 0. 0 minus 0, this will become s into I. This implies di by ds, this is equivalent to minus half Si. Now, this is a first order differential equation. Here it contains only two variables, one is I, another one is small s. So in this way, we can solve this first order differential equation by using the method of variable separable. Variable separable in the first year M1, you have that one, you had that one, understanding? So in this way, by using variable separable method, how you can make it, how you can alter the differential equation, keep all I words terms one side, this will become minus s by 2 of minus s by 2. Taking ds that side, this become ds. Now integrating both sides, this will become integral di by I with respect to di, understanding, di by I, that is equivalent to minus half into integral s ds plus some constant, that is log c. So this will become di by I will become log I, that equal to minus half into for s square by 2 plus log c. So this will become minus s square by 4 plus log c. So now log I equal to this one. Here this is a natural logarithm. So base equal to what? E. This implies I is equal to e power minus s square by 4 plus log c. Now this can make e power minus s square by 4 into e power log c. So log c means what? C. C into e power minus s square by 4. Therefore, the integral equal to I. I means what? The Fourier sine transformation of e power minus t square. Its value equal to some constant into e power minus s square by 4. This is very important problem. Now just look at. So based on that one, students have to make a practice how to find Fourier cosine transformation of e power minus t square. That problem is left for you for your exercise purpose. You make it Fourier cosine transformation of e power minus t square. Understanding? Now here, two important steps students have to understand. Just directly write the Fourier sine transformation here. Say it be I, t is missing to get e power minus t square completely integrable. For that purpose, the integral is given with respect to t. There is one more variable s. So we are differentiating the integral with respect to that s. In that case, as long as we are differentiating, the variable t will become constant, sine will become cos st, t variable will become just. So multiplying both sides by minus 2 and dividing by minus 2. Understanding that now the integral is integrable. After that, we are using UV method. Just let us consider this is UV method. Go for this one. Understanding e power minus t. So now this is the purpose of this one. Here one more point. In the integral, here just you are supposed to make it now. Just look at here that word I forgot to write. This is cos st. Cos st minus. Then here also just have to make it keep e power minus t square into cos st between 0 to infinity. So that value will become 0, cos st. So here that cos st is differentiable here minus sin st. So this is the output. At last what we got? This is di by ds. we got a simplification of minus s by 2 into I. After moving by variable separable method of the first order differential equation, just we separated I variable separate and s variable separate. After that integrity, just we got this the output. Now just look at this, the only simplification part is going on here, no, not more than that one. At last I, we got this one, because I stands for what? Fourier sine transformation of f of t. So this is the way of calculating Fourier sine transformation of e power minus t square equal to c into e power minus s square by 4. Very important concept. Students are advised to concentrate on this problem. Now the last one, Fourier cosine transformation of e power minus t square, that is left for you. You have to make it on your own for your practice purposes. In these two, any one possibility is to get the same problem in the next examination. Thank you.